Good afternoon. In our next class in the neuroanatomy series, today we are going to discuss about the cerebrum, which is unarguably the most important part of human central nervous system. Since cerebrum is a relatively vast topic, we are divided the discussion of cerebrum into two parts, part 1 and part 2. So we'll be seeing the part 1 in our first session. The specific learning objectives of part 1 include the external features of cerebrum and the sulci and the gyri. Of course, these features have to be ascertained by studying a specimen of the brain in the dissection hall. We will start with the external features of cerebrum. The cerebrum is the largest part of the human brain that fills most of the cranial cavity. Its large size is a result of a progressive centralization, or what you call as telencephalization, of the various higher sensory and motor centers of the brain during evolution. The cerebrum is a heavily convoluted bilobe structure, as you can see from this picture. The two lateral halves are called cerebral hemispheres. A deep median cleft, the longitudinal cerebral fissure, incompletely separates the two cerebral hemispheres, both in front and behind. This cleft is complete, but in the central part, the cleft extends downwards up to the corpus callosum, which is a large mass of white fibers joining the two cerebral hemispheres across the median plane. Each cerebral hemisphere consists of an outer layer of grey matter called as the cerebral cortex, an inner mass of white matter, large masses of grey matter embedded in the basal part of the white matter known as the basal ganglia or the basal nuclei, and a cavity within the cerebrum which is called as the lateral ventricle. The cerebrum consists of grey matter, white matter, basal ganglia and lateral ventricle. The external features of the cerebral hemisphere include the poles, surfaces, borders, sulci and gyri. First we will see about the poles. Each cerebral hemisphere presents three poles, as you can see from the picture: frontal, occipital and temporal. The frontal pole is at the anterior end of the hemisphere. It lies opposite the medial part of the superciliary arch. The occipital pole is at the posterior end of the hemisphere. It lies a short distance supralateral to the external occipital protuberance. The temporal pole between the frontal and the occipital poles points forwards, and it fits into the anterior part of the middle cranial fossa and is overhung by the lesser wing of sphenoid. Each cerebral hemisphere has got three surfaces: supralateral, medial and inferior. This slide shows the supralateral surface. The supralateral surface is the most convex and the most extensive. The medial surface is shown in this picture. It is flat and vertical, and it presents a thick C-shaped curved surface of the corpus callosum. So this is the medial surface. The inferior surface is irregular to adopt the flows of the anterior and middle cranial fossae. It is divided into two parts by a deep horizontal groove or sulcus. which is called as the stem of the lateral sulcus. The two parts are a small anterior part, which is called as the orbital surface, and a large posterior part, which is termed as the tentorial surface. Each cerebral hemisphere presents 6 borders, namely supromedial, superciliary, inferolateral, medial orbital, medial occipital, and infromedial. The supromedial border, which you can identify in this picture, separates the superolateral surface from the medial surface, and it's the most important from the anatomical point of view. Now we will see the sulci and the gyri of the cerebrum. The cerebral cortex, that is the surface layer of grey matter, is highly extensive in humans. To accommodate it in the limited space available within the rigid cranial cavity, the surface of the cerebral hemispheres become highly folded, producing numerous convolutions separated by fissures. These convolutions are termed as gyri, and the fissures are termed as sulci. In human brain, the total surface area of the cerebral hemisphere is about 200 centimeters square, but approximately 2/3 of this is hidden from the surface view within the walls of the sulci. The sulci vary in depth from slight grooves to deep fissures, whereas the gyri consists of a central core of white matter covered by a layer of grey matter, the cerebral cortex. Of course, there is a great deal of individual variations in the details of the sulci and the gyri on the cerebral cortex. The following description deals with the only some important sulci and gyri. Now we will see some of the major sulci and the gyri of the cerebral cortex. First, we will see the lateral sulcus, or it's also called as the Sylvian fissure. Lateral sulcus is the most conspicuous of all the cerebral sulci and has a stem and 3 rami. The stem of the sulcus begins as a deep cleft on the inferior surface of cerebrum at the anterior perforated substance and extends laterally between the temporal pole and the posterior part of the orbital surface. On reaching the supralateral surface, it divides into 3 rami or branches, namely anterior horizontal, anterior ascending, and posterior. So this is the lateral sulcus or Sylvian fissure. Now coming to the second important sulcus, the central sulcus, also known as the fissure of Rolando. The central sulcus begins by cutting the supromedial border of the hemisphere about 1 centimeter behind the midpoint between the frontal and the occipital pole, runs downwards and forwards, and ends just above the posterior ramus of the lateral sulcus. Its upper end usually extends into the medial surface. The central sulcus is important because it forms the boundary between the motor area of the cerebral cortex in front and the sensory area in behind. And it is also important in that it is the only sulcus that indents or cuts the supromedial border of the hemisphere, and this sulcus serves as a key to localize the other sulci and gyri. Two other important sulci are seen on the medial surface. The first one represented by the down arrow, is the calcarine sulcus. It begins as a deep fissure a little below the posterior end of the corpus callosum, the splenium, and follows an arched course with a convexity upwards to the occipital pole and may extend slightly onto the superolateral surface. The second sulcus, marked by the transverse arrow, is the parieto-occipital sulcus. It begins at the midpoint of the calcarine sulcus, courses upwards and slightly backwards to cut the supromedial border of the hemisphere about 5 cm in front of the occipital pole. Now we'll see the lobes of the cerebral hemisphere. To discuss further about the sulci and the gyri and other aspects of the cerebral hemisphere, the superlateral surface of the hemisphere can arbitrarily be divided into 4 lobes: frontal, parietal, temporal, and occipital, with the help of the 3 main sulci, central, lateral, and parieto-occipital, and 2 imaginary lines. The first imaginary line is a vertical line joining the parieto-occipital sulcus to the pre-occipital notch, and the second line is a backward continuation of the horizontal part of the posterior ramus of the lateral sulcus till it joins the first line. Now we'll try to see the 4 lobes. The frontal lobe lies anterior to the central sulcus and above the posterior ramus of the lateral sulcus. The parietal lobe lies behind the central sulcus and in front of the upper part of the first imaginary line. The temporal lobe lies below the posterior ramus of the lateral sulcus and the second imaginary line, and the occipital lobe lies behind the vertical line joining the parieto-occipital sulcus and the pre-occipital notch. Now we'll see a special part of the cerebral hemisphere which is called as the insula. It is also known as the island of Riehl or the central lobe. It is customary to consider the insula separately from the 4 main lobes of the cerebral hemisphere that we have seen previously. The insula is in fact the submerged or hidden portion of the cerebral cortex in the floor of the lateral sulcus. The insular cortex is triangular in shape and surrounded all around by a sulcus called as the circular sulcus. The insula is divided into 2 regions, anterior and posterior, by a central sulcus. The anterior region presents 3 or 4 short gyri called as gyrae brevia, whereas the posterior region presents 1 or 2 long gyrae called as gyrae longa. The insula is hidden from the surface of the cerebral hemisphere by the overgrown cortical areas of frontal, parietal, and temporal lobes. These areas are termed as frontal, frontoparietal, and temporal opercula. The word operculum literally means a lid. Does the insula play any important function in the human brain? It is for you to find out and tell me. Now we'll try to see in detail about some of the major sulci and the gyri on the different surfaces of the cerebral hemisphere. We will start with the sulci and the gyri on the superlateral surface of cerebral hemisphere. First we will see the important sulci on the frontal lobe. The central sulcus runs downwards and forwards parallel and a little anterior to the central sulcus. The area between the central and the precentral sulci is called the precentral gyrus. So the precentral sulcus and the precentral gyrus. Anterior to the precentral sulcus, there are two sulci called superior and inferior frontal sulci which run horizontally. These sulci divide the region of the frontal lobe in front of the precentral sulcus into superior, middle and inferior frontal gyri. So from the picture, try to identify the superior and inferior frontal sulci and superior, middle and inferior frontal gyri. The anterior and ascending rami of the lateral sulcus divide the inferior frontal gyrus into three parts. The part below the anterior ramus is called pars orbitalis. The part between the anterior and the ascending rami is called as the pars triangularis, and the pars posterior to the ascending ramus is called as the pars opercularis. So try to find out the anterior and ascending rami of the lateral sulcus and the three gyri, namely the pars orbitalis, pars triangularis and pars opercularis. So in the frontal lobe, try to identify the precentral sulcus and the precentral gyrus, then the superior and inferior frontal sulci and the superior, middle and inferior frontal gyri, the ascending and anterior rami of the lateral sulcus, and the three regions in the inferior frontal gyrus, pars orbitalis, triangularis and opercularis. Now coming to the parietal lobe, the postcentral sulcus runs downwards and forwards, a little behind and parallel to the central sulcus. The area between these two sulci is called the postcentral gyrus. The rest of the parietal lobe, as you can see, is divided by the intraparietal sulcus into a superior and inferior parietal lobules. The upturned posterior end of the posterior ramus of the lateral sulcus and the posterior ends of the superior and inferior temporal sulci extend to the inferior parietal lobule to divide it into three parts. The part that surrounds the posterior ramus of the lateral sulcus is called supramarginal gyrus. The part surrounding the superior temporal sulcus is called as the angular gyrus, and the part surrounding the inferior temporal sulcus is called as the arcus temporo-occipitalis. So, in the parietal lobe, you try to find out the post-central sulcus and the post-central gyrus. Then, the intraparietal sulcus dividing the parietal lobe into superior and inferior parietal lobules. Now, coming to the temporal lobe, the two sulci that run parallel to the posterior ramus of the lateral sulcus are termed as superior and inferior temporal sulci. These divide the temporal lobe into superior, middle and inferior temporal gyri. The superior surface of the superior temporal gyrus presents two transverse temporal gyri. The anterior transverse temporal gyri is also called as the Heschel's gyrus, the importance of which we will see later on. So in the temporal lobe, try to identify the superior and inferior temporal sulci and the superior, middle and inferior temporal gyri. And now coming to the occipital lobe, it possesses three rather short sulci: the lateral, transverse occipital and lunate sulci. The occipital lobe, try to identify the lateral, transverse occipital and the lunate sulci. Now we will see the sulci and the gyri on the medial surface of cerebral hemisphere. The presence of corpus callosum, represented by the arrow, is the most conspicuous feature on the medial surface of the cerebral hemisphere. It's a C-shaped thick bundle of fibers consisting of a central part, the trunk, a thick posterior end, the splenium, and a curved anterior end, genu. The sulci and the gyri on the medial surface are located above, in front, and behind the corpus callosum. The callosal sulcus lies just above the corpus callosum. Cingulate sulcus. It is the most prominent sulcus which follows a curved course about 1 cm above and parallel to the upper convex margin of corpus callosum. The area between the cingulate sulcus and the corpus callosum, or more appropriately the callosal sulcus, is termed as a cingulate gyrus. Now just try to identify an important area called as the paracentral lobule, which you can see in the picture. The boundaries of the paracentral lobule needs to be elaborated, as it is a cortical or the highest center of micturition and defecation. The paracentral lobule is bounded above by the supromedial border of the hemisphere, below by the cingulate sulcus, and posteriorly by the upturned posterior end of the cingulate sulcus. The paracentral lobule is invaded by the downturned upper end of the central sulcus. The posterior part of the medial surface behind the paracentral lobule has two main sulci, the calcarine sulcus and the parieto-occipital sulcus, which I have already seen earlier. The triangular area between the posterior part of the calcarine sulcus and the parieto-occipital sulcus is called the cuneus. The quadrangular area between the parieto-occipital sulcus and the paracentral lobule is termed as precuneus. So, in the medial surface, you have to identify the corpus callosum, callosal sulcus, cingulate sulcus and cingulate gyrus, the paracentral lobule and its boundaries, the calcarine sulcus and the parieto-occipital sulcus, and the two gyri, the cuneus and precuneus. The important gyrus highlighted in this picture is the paracentral lobule. We have already seen the function of the paracentral lobule and its boundaries. Please note, the paracentral lobule is indented by the downturned upper end of the central sulcus. We will quickly see the sulci and the gyri on the inferior surface of the cerebral hemisphere. On the orbital part of the inferior surface or the orbital surface, you can see the olfactory sulcus, which lodges the olfactory bulb and the tract, and the gyrus lying medial to the olfactory sulcus is called as the gyrus rectus. The orbital sulcus is an irregular H-shaped sulcus and divides the rest of the orbital surface into anterior, posterior, medial and lateral orbital gyri. So, on the orbital part of the inferior surface, try to identify the olfactory sulcus, the gyrus rectus and the orbital sulcus. Now moving on to the tentorial part of the inferior surface. This surface is marked by two major sulci that run antero-posteriorly. The medial one is called collateral sulcus and the lateral one the occipito-temporal sulcus. Posteriorly, the collateral sulcus is parallel to the calcarine sulcus, and here the area between these two sulci is termed as lingual gyrus. Anteriorly, the lingual gyrus is continuous with the para-hippocampal gyrus. If you see the para-hippocampal gyrus, it forms a hook-like anterior end which is termed as the uncus, the functional importance of which we will study later. So, these are the important sulci and the gyri to be identified on the tentorial surface. The collateral sulcus and the occipito-temporal sulcus, the lingual gyrus, the para-hippocampal gyrus and the hook-like anterior end of the para-hippocampal gyrus, which is called as the uncus. In this picture, you can once again identify the important sulci and the gyri on the tentorial surface: the collateral sulcus, the occipito-temporal sulcus, lingual gyrus, para-hippocampal gyrus and the anterior end of the para-hippocampal gyrus, which is termed as the uncus. So in this first part of the anatomy of cerebrum, we have discussed about the external features of cerebrum and have also seen the important sulci and the gyri of the cerebral hemisphere. Since your brain is too saturated with lots of information, we'll take a break and come back to discuss about the functional areas of the cerebral cortex in our part 2 class. Thank you.